I'm going to give you the overview of IP addressing. Since a lot of students has doubt understanding IP addressing, let me start with the topic IP addressing. What is the basic of IP addressing? What is classful addressing, classless addressing? So, to understand IP addressing, let's understand what is the primary job of IP addressing. Whenever we need to give IP addresses to any devices or any host, what we need to do is just go to the configuration of the devices and we give a IP address. Now, why we need to give a IP address? Since these are the primary jobs given in the slide: delivering messages, network interface identification, routing. But the primary job is to identify a device. Primary job is to identify a device by its address. For example, I want to identify a particular person by a name. Sometimes if the person is a student, for example, you all guys are a student, so I need to identify sometimes by some enrollment number when I call your roll number. So I need to give some number, or here in this case also, when I'm giving IP address, I'm giving some number to identify a particular device. So why IP addressing? Why IP addresses? Now, even though since each and every hardware addresses having MAC addresses, hardware addresses, why I should give IP address? IP address is generally come from Internet Protocol. Now, Internet Protocol is a layer 3 protocol. What is layer 3? Since all of you know that in a WSI model there are 7 layers. So now layer 1 is physical layer, layer 2 is data link layer, layer 3 is network layer, and similarly in TCP/IP protocol suite model we have internetworking layer. Now this layer generate a address which helps particular device to be identified in a network so that it can communicate. Now, what is IP address? IP address generally, when we use, it's a binary address, but it's a 32-bit binary address, but it is actually represented by dotted decimal notation. Now, it's a 8-bit, 4 8-bit octet. So, for example, here in this case, if you see this particular address, if you convert this particular address to IP address, here in this case this is not IP address. So if you convert this particular address into IP address, you need to know how to convert a binary number to a decimal number. We will learn this. So generally this is a 32-bit binary address. So if it is a 32-bit binary address, we represent it with a dotted decimal. So we'll talk about subnet later. So IP addressing structure, for example, this is IP address 227.82.157.177. So if you pick up any 8-bit number, for example 0 1 1 0 1 1, and this 2 if it is 0, how to convert this particular binary number 8-bit 1 2 3 4 5 6 7 8, this particular 8-bit number into decimal number? This value is 2 to the power 0, nothing but 1. This is 2 to the power 1, 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. So if you convert this, you add the corresponding numbers. So for example, 32 plus 16 plus 4 plus 2, that is 54, I think. So 32 plus 16 is 48, 52, 54. So this, if you convert this particular binary number into decimal, this is 54. And similarly, you can convert any decimal number into binary. So 177 is, it is very easy. Just first write what is the corresponding value of each and every bit. So you need to know the corresponding value of only 8 bits. So it is 1, 2, 4. It is 2 to the power 0 to 2 to the power 7. So 32 bit, basically this number has two portions. Okay, this entire 32 bit, this 32 bit is having 4 block. This is first block, this is second block, this is third block, and this is fourth block. Now this 4 block generally has this entire 4 block generally divided into 2 parts. And this, when we start learning about classful addressing, this is fixed, and when it is classless, it is not fixed. I will talk to that later. Now 32 bit internal structure of this particular IP addresses, this is having 2 portion, network portion and host portion. That is why it is written here, that is network identifier and host identifier. So here in this case, this is 8-bit network ID, 24-bit host ID, depending on the on different classes. So IP address scheme, what I was talking about, this is divided into 2 parts. One is classful address, one is classless IP address. So if we talk about IP addressing, we need to know 2 things. One is classful addressing and one is classless addressing. This subnetting and supernetting we'll discuss later. Now what is classful addressing and what is classless addressing? Now in classful addressing, what do we mean by class A, class B, class C, class D and class E, and how these are classified? Now I'm just going through this slide of Verizon, and let me tell you, give you an introduction of classful addressing. Now these are the address space. Now there are a few golden rules when we talk about IP addressing. The entire address space is 2 to the power n. Here n is 32 bit. Now this is called IPv4 addressing. We have 2 types of IP addressing. One is called IPv4, one is called IPv6 addressing. So my address space is 2 to the power 32. So I should have 2 to the power 32 numbers. So many numbers of IP address I should have. Okay, but this entire address space is divided into 5 categories or 5 classes when we talk about classful IP addressing. Okay, so skip this portion. When we talk about this entire classful addressing is divided into 5 different address spaces, A, B, C, D and E. These are called classful addressing. So what is the requirement of classful addressing? When I started talking about IP addressing, now when I started talking about IP addressing, I already told you there are 2 things. One is network portion, and the first block is called network identification portion, and remaining is called host portion. Now I need to have one golden rule, is that, for example, these 2 hosts are talking with each other, or 2 devices are communicating with each other. Basic rule has their network portion need to be common. Okay, so their network ID need to be common and their network portion need to be common. So if their network portions are common, then I need to fix the network bits. So for example, if I take the example of 192.168.1.1 and 192.168.1.2, here in this case you can see this entire portion is common. Okay, so for different classes, class A, class B, class C, class D, class E, okay, the different portions are common. So there is a different mechanism how we classify this. Okay, for example, when we have this 4 byte number, first byte, second byte, or 4 block number, this first 8 bit, this first 8 bit will help me to identify which class it belongs to. Now if it start with 0, that means this belongs to class A. So what do I mean by the number, the first block, the first bit is fixed, the first bit is fixed with 0. That means if you see the entire values of all the 8 bit, this first one is 1, the second one is 2, then 4, then 8, then 16, then 32, 64, and then 128. That means the number has to be less than 128. So that means it is in between 0 to 127. So I can actually identify that if my number belongs to class A, it is in between 0 to 127. Now if it is 10, that means I calculate in a different way. If it is 10, that means 128 plus 64 is 192. So it has to be less than 192. How? Means if it is 10, then remaining all bits are 1. Then this value will be 191. Okay, so this will be from 128, because this will be fixed 128 to 191. Okay, now similarly for in case of class C, it has to be the value will start from 192 to if it is 110, then it will be 110 means if I fix it to 110 and remaining all bits are 1, then it has to be 224. So it will be in between 192 to 223. Class D, then again 224 to 239, and this will be 240 to 255. Like that, by seeing the first 8 bit, I can classify, I can actually split that in this entire range of IP address space into 5 different classes. Now what is the algorithm? How to check this entire or this particular IP address belongs to which class. So if first bit is 0, class A. If not, then it is 1. Then the second bit is 0, then it is class B. That's how the the network identifies which class it belongs to, and then they start communicating, and that is how they do the mapping. They compare two IP addresses. Now third bit, if it is 0, then it is class C. Like that, by identifying first few bits, we can identify which class it belongs to. Now class A, B, class C used for commercial purpose. D and E are used for research and other activities. D is basically multicasting address, E is research activities. Now from this we can see that class A has 2 to the power 31 number of addresses. One bit is fixed, so it should have 2 to the power 31 addresses. Now I'm skipping this part. Now this is what we have calculated. The first bit, if it is 0 to 127, this is class A. 128 to 191, this is class B, class C, class D, class E. Now in case of class A, the first block is network portion, and remaining 3 blocks are host. So in case of class A, it is first, and remaining 3 blocks are in host. In class B, it is balanced, 2 blocks in network and 2 blocks in host. When we discuss in details, we'll tell you later. This 3 blocks in class C and 1 block in class, okay, 1 block in host. So what do I mean by that? That means how many hosts is possible in class A. So 3 blocks means 28 bit. So how many blocks, how many numbers in a block? 2 to the power 24. Now there is a golden rule: all host bit cannot set to 0, that is called network address, and all host bit cannot set to 1, that is called broadcast address. And that is why we miss 2 addresses always when we calculate IP addresses. So a single normal class A address is class full address should have 2 to the power 24 minus 2 number of hosts. In class B, it has to be 2 to the power 16 minus 2. In class C, it has to be 2 to the power 8 minus 2. Now that is what I was talking about. Class A, this first 8 bit, then remaining 24 bit. In class B, it is 16 bit. Class C, it is 24 bit, 8 bit. So in a network, how many number of hosts are possible? This is what it is calculated, and D and E is multicast and reserved for future use and other purposes. So how we actually identify each and every block, that we'll talk later. So this is my blocks, calculation of blocks. So in the next segment, we are going to discuss about classful and classless IP addressing.